Classifying and comparing quadrilaterals. Discover. And there's Olivia, and she's playing there with some geostrips, making different shapes. They're all four-sided shapes, which makes them quadrilaterals. Question 1 says, Olivia is making shapes with geostrips. What is the same and what is different about the shapes she has made? And question 1b, what shape is a regular quadrilateral? So question A, quadrilaterals can have different lengths and different angles from each other. One thing that they all have in common is that 4 sides. Olivia's shapes all have 4 sides, but each has different angles. And question 1b, the quadrilateral with 4 equal sides is called a rhombus. The interior angles of a rhombus may be different, but its sides are all the same length. So if we look at these different types of rhombuses, and actually a square is a rhombus. And one way I think of a rhombus is a square that's kind of been pushed over a little. So imagine this green rhombus was a square and it's been slightly pushed over. So all the sides are the same length, but the angles now have changed. This is an acute angle. It's less than a right angle. And this is an obtuse angle, because it's bigger than a right angle. A square is the only regular quadrilateral and is a special type of rhombus. It has 4 equal sides and 4 equal angles. So a regular quadrilateral or a regular rhombus is a square. All sides are equal. All interior angles are equal. They're all right angles. And these irregular quadrilaterals, the interior angles and all the sides are unequal. So you can see this one has longer sides and shorter sides. This one has all angles the same, but the sides are different sizes. Think together. A parallelogram is a quadrilateral which has 2 pairs of parallel sides. Identify all the parallelograms. Well, I always think of parallel sides as 2 lines that will never meet. No matter how far they go along, they will never meet. One example that we always say is like railway tracks. When you think of a train going along the railway tracks always stay the same distance, because if they went further apart or closer together, the train would come off the tracks. So let's look at shape A. We've got the opposite sides here, and if I drew them longer and longer on the dots, they would never get closer or further away. So those are parallel. And these sides here on the left and the right, yes, no matter how long I drew them, as long as I kept them straight, they would never touch each other or go further away. So shape A is a parallelogram. Now, if we have a look at B, the top and the bottom lines, yeah, they are parallel. But if we look at the sides, what would happen if we continue to draw them? They would cross over. Yeah, so shape B is not a parallelogram, even though it does have 1 set of parallel sides. Shape C, we've got the side diagonal lines are parallel. They would never meet if you carried on drawing them. And the top line and the bottom line, these opposite sides, are parallel as well. Yes, that is a parallelogram. And shape D. Let's have a look at this side and its opposite side. Yes, they're parallel. And this side and this side, yes, they're parallel. They would never cross each other. So 3 of those shapes are parallelogram. And how do you know? Because parallel lines are 2 lines that are always the same distance apart and never touch. And question 2, a trapezium has 1 pair of parallel sides. The other pair of sides can be the same length or different lengths. Draw a different trapezium to the one pictured here. Use squared paper to help you. Well, if you've not got squared paper, let me have a go for you. Right, I'm going to do my first line there, and then I'm going to draw my second line there. Are those lines parallel or not? Have a little think. Do you think they're parallel or not? Yes, they are parallel. They would never touch. Now, I'm going to fill in the sides. Will these new set of sides ever touch? Yes. If I carried on drawing them down, eventually they would meet in the middle. And if I carried on drawing them this way, they would get further and further apart. So are those sides parallel? No, they're not a parallel line. So that is a trapezium. And trapezium is different from a parallelogram because it's only got one set of sides that are parallel. The other set of sides are not parallel. And if you finish all the work in your book, have a go at the challenge questions. Answers are at the end of the video.